Running the full TPC-DS benchmark of all 99 queries on the same 100 GB dataset, the Transwarp GPU-Native Cognitive Database completed it in 10 seconds. A cloud database took 7 minutes and 12 seconds. This is the most tangible gap between a GPU-native architecture and a traditional one. In other words, in the time it takes cloud database to complete a single run, the Transwarp GPU-Native Cognitive Database has already completed approximately 43 of them. At the 1 TB scale, both the Transwarp Cognitive Database and the open-source CPU-based DuckDB completed the full TPC-DS benchmark. The overall throughput was 94.56 million for the Cognitive Database compared to 1.35 million for DuckDB, a 70 times gap. Every one of the 99 queries was faster on the GPU, with individual query speedups ranging from 2 to 480 times and a median of approximately 61 times. 30 queries showed speedups exceeding 100 times. This conclusively demonstrates that the Transwarp GPU Cognitive Database consistently outperforms CPU databases across all workloads. Yet performance numbers ultimately need to prove themselves in real business scenarios. The following 3 core use cases demonstrate how the cognitive database translates its performance advantages into tangible business value. Financial risk management. The cognitive database supports natural language interaction, enabling risk teams to analyze data directly without writing SQL. It achieves 307 times, 449 times, and 353 times speedups in risk volatility, attribution, end-to-end credit analysis, and vintage analysis respectively, with sub-second response across 480 million detailed records. Risk teams can identify risks earlier and accelerate decision-making. Quantitative investment research. The cognitive database unifies data storage, factor computation, and strategy logic onto a single GPU platform. Speedups range from 12.2 times to 5,881 times across algorithms, including transaction cost analysis, cross-asset ETF arbitrage, Monte Carlo pricing of snowball options, and Monte Carlo pricing of European options. Backtesting cycles shrink from days to minutes, enabling quantitative teams to accelerate strategy validation and capture investment opportunities sooner. Enterprise data warehouse migration and self-service analytics. The cognitive database enables business users to directly obtain insights through multi-tenant isolation and natural language queries, reducing time to insight from weeks to minutes. It also supports one-click migration from cloud database platform, with existing tool chains directly compatible, shorter migration cycles, and significantly lower total cost of ownership. Then why is GPU so much faster than CPU? First, compute power. A traditional CPU has 10 to 200 cores, with compute capacity of 0.12 to 1.7 teraflops, excelling at low-latency serial computation. A modern GPU, such as the NVIDIA Blackwell Ultra, has 10,000 to 20,000 cores, with compute capacity of 75 to 105 teraflops. Through massive thread parallelism, it can process enormous volumes of data simultaneously. The difference in core count spans to orders of magnitude, and compute performance can be tens of times higher. Next, bandwidth. CPU memory bus bandwidth is 100 to 400 gigabytes per second, while GPU HBM bandwidth is 1.6 to 8 terabytes per second, a gap of more than an order of magnitude. Higher bandwidth means more data can be transferred per second, which is critical for large-scale analytical workloads. What do we use to validate the performance of a GPU-native database? TPC-DS, the industry's most authoritative decision support system benchmark. It is not a simple single-query benchmark, but a complete analytical database workload, 99 complex SQL queries. At TPC-DS SF1000, the 1 terabyte scale, the Transwarp Cognitive Database completed all 99 queries and insert, delete, update operations with zero fallback to CPU. Everything executed entirely on the GPU. GPUs are powerful, but a common question comes up. GPUs are more expensive than CPUs. How does the math work? The reality is that the per-instance hourly rate of the Transwarp Cognitive Database is identical to that of cloud database. At equal cost, the gap shows up in 2 ways. If we control for time, the Transwarp Cognitive Database can process approximately 43 times the data volume of cloud database, In the time Cloud Database completes one test, the Transwarp Cognitive Database has already completed 43 of them. If we control for data volume, at the same 100 GB scale, running the full TPC-DS benchmark, the Transwarp Cognitive Database completed it in 10 seconds, while Cloud Database took 7 minutes and 12 seconds, approximately 43 times the processing speed of Cloud Database. At a larger scale, the TPC-DS 1 TB benchmark shows that the Transwarp Cognitive Database achieves a performance gain of 22.4 times to 41.3 times over Cloud Database, with a price-performance ratio improved by 4.3 times to 14.1 times. Equal cost, greater data processing capacity. Equal data volume, faster processing speed. This is the value of a GPU-Native Cognitive Database. Unleash GPU-Native performance. Request a free trial now.